What we discussed in last class, in yesterday's class? What we discussed in yesterday's class? Regarding what?
Unit answer.
Huh? Yesterday, what we discussed?
Revision of Unit 1, sir.
Yes, yes, yes. It is nothing but for mid-examination point of view. First mid-examination point of view, three things we discussed actually. The first one is the question paper pattern, how it looks like. Question paper pattern, okay. And the second thing is distribution of the units in that question paper, okay. Which question can be expected as under the first unit, which question can be expected as under the second unit, like that we have seen, okay. Only the set one only we have taken, but thing is total two sets can be expected, two sets, not a single set, okay. If one set one student have been got, means the second person, the next immediate who has occupied the seat, he will get the second set. 1 2 1 2 1 2, like that M set pattern is going to be followed, okay. So according to that MCET pattern only you are going to get surrounding. If you check, no one will get the same set whatever you got. So there won't be any chance of doing any malpractice things. So be careful about that. Okay. Since descriptive examination, this is, and it is of how many hours? Mid examination?
2 hours.
2 hours. Okay. And how many marks that it carries?
25.
25 marks. Okay, 5 marks for assignment. Okay, so assignment 5 marks, 25 marks descriptive exam only, mid one, and two sets are going to be prepared by the subject in charges, and you are going to write any one set that nobody knows which set will come. Today if you got in one particular subject as set 2, tomorrow there won't be any guarantee that you will get set 2 only. Set 1 might be the starting set in that particular classroom, like that they were going to give. Don't think that always if in first exam I got set 1 means always I will get set 1 only. It's not like that, okay. So to explain about the important questions as well as the examination pattern, now what I'm going to do is again I'm going to show that question paper to you. Let me share my screen first. Yes. And in today's class, we are going to discuss about important questions in second unit. Okay. So in first unit, whatever the important questions are there, let me once again in brief, let me show that slide. Okay. Here, if you take this slide, you came to know that what are all the important questions are there in first unit. Unit 1, if you take short answer questions, important questions, and long answer questions, important questions, if you take, they can be expected as like this. Okay. So blue color, whatever the topics are there, they will comes under the short answer questions. Okay. And whatever the color was given for as the red color, they will comes under the long answer question. Okay. The first question in this introduction to quantum physics is black body radiation. Explain about the black body radiator, like that can be expected as under the short answer question. Okay. Next, Compton effect can also be expected. Heisenberg uncertainty principle. Four questions I am giving you for preparation for mid examination as under the first unit. Okay. So these are all the important short answer. For example, these two questions, if at all was taken given in the set one, then the remaining two can be expected in set two. Set 1 and set 2 question papers, if you observe the questions, they may not be same. No repetition will be there. Whatever the questions you got in set 1 cannot be expected the same questions in set 2 also. Okay. So we can expect four questions minimum as the important questions. If you take 100%, these will come also. Thing is, four questions have been taken as the important questions. Why? Because two from set 1, two from set 2, which in which combination they will come, even we too don't know actually. Okay. So they will, these in unit 1, these are all the short answer questions, important short answers questions. Okay. Remaining topics are also there, but we can expect they will be not that much important. Okay. Even though if they comes also, thing is you should be in a position to write something about these things like black color, whatever I have given, Planck's law, never been asked actually, even in semester end exam also. Photoelectric effect is there, and waves and particles. These were never been asked as under the short and long answer questions. Okay. Now, answer questions in Unit 1. De Broglie hypothesis and the applications and define matter waves and differentiation as under the long answer question, 10 to 12 marks like that. Okay. And the second question is David Germer's experiment, which is very, very important. Damn sure question. But in which set it will come, nobody knows. For example, if first two have been given in the second set, then the remaining two can maybe they will give in the set one as like that. But thing is, no question will be repeated in both these question papers. Okay, that thing is very clear. Okay, so Schrodinger's time independent wave equation, derive Schrodinger's time independent wave equation is there na, that can also be expected as the long answer question. And particle in a potential box, two long answer questions for one set, two long answer questions for second set. But which set, in which set which question will come, nobody knows. Thing is, these four if you have concentrated, then definitely you can write whatever the questions were given in the question paper like that. Okay, is it okay? Am I clear? If everything is clear, then we will move to the next step. That is, once again we will see the mid examination previous question papers, in which what was asked under the unit 1 we will see. Next we will move to the unit 2 questions. Unit 2 questions, important questions in unit 2. Among these topics, you are expecting anything to be reviewed once again, revision of, only thing is matter of 1 or 2 minutes only I will take to complete that revision. Okay, if everything is okay, we can write, no problem. Only thing is our side preparation is pending means I will leave the unit 1. It's up to you, you have to decide. One or two students, please speak out so that whether I have to go to the second unit, or here any doubts if you have, then I'm going to clarify. Anything you want to ask, you can ask your doubts, anything. Okay, so this is about the unit 1. Let me close this unit 1. Nobody is speaking out, is nothing but everything is clear like that. I can expect. Okay, now let me move to the unit 2. Let me move to the unit 2. Okay, so in unit 2, first, let me take the question paper first itself. Okay, set one and set two, how they were framed, how the questions are going to be asked. First, we will see. Okay, as all you know that part A will be there, short answer questions, and part A is compulsory, which carries a 10 marks. Compulsory means here 1AB from unit 1, 1CD from unit 2, and 1E. This last question is from unit 3A, means first part. Okay, already we have told about this. Okay, so each question you see it is carrying equal marks, 2 to 2 marks it is carrying. Okay, CO1 is nothing but a course outcome of the first unit. Here itself, it is indicating that from which unit actually these questions were framed. CO1 is there, means first unit. Course outcome of the first unit. So first unit. From first unit, you are getting two questions. Here, Compton shift. Explain about the Compton experiment and Compton shift with a need diagram. Okay. And the second question is define matter waves. Differentiation is nothing but comparing matter waves with X-ray waves. Both will comes under the unit 1. So over. So this part is over. Part A, two questions are over as under the short answer questions. Now, remaining these two questions, if you take 1C and 1D, they were from second unit. You see, course outcome of the second unit. Course outcome of the second unit. Okay, this BL stands for Bloom's level. Actually, level of asking the question. BL stands for. Okay, total we are having the five levels are there actually. Among these levels, any one level will be asked. Fifth level is nothing but highest level. Okay, fourth level is little bit lower level. First level 1 is nothing but Bloom's level 1 is nothing but asking about that definitions, what is this, what is that, lowest level actually. Okay, so 3 is apply level, like that 4 is analysis level, 5 is evaluation level, and sixth level is the creation level, like that there are some levels are there. While framing the question paper, the concerned subject faculty will take care about which level of questions have to be given, which levels of questions to be prepared. He will take care about that. Only that thing is here. Bloom's level 2. Bloom's level is 2. That not the unit number actually. Okay, but these are all nothing but first unit course outcome. First unit course outcome means first unit two questions you got. In second unit you got two more questions. In last third unit first half you got one question, as like this. Is it clear, students? Please respond whenever I will ask any question. Immediately if you respond, then I will think that everything is okay.
Yes, sir.
Okay, okay. So there won't be any confusion here. This part A carries 10 marks. Okay. Now this is actually the set one. This is actually set one. Now if you move to the part B only, in this set one only, in set one only, part A is over. Na? Now if you move to the part B, now which question was given under which unit, again you see. Part B is long answer questions. All part A questions are short answer questions. All part B questions are long answer questions. Now, this question, if you take, there won't be any confusion. Here itself, we can see this is from unit 1. This is from unit 1. Part B carries 15 marks. Now, you see, this carries here 3 marks. And so, followed by theory under unit 1, there is one problem is also given. A microscope using, this is actually the previous question paper only. Don't think that I'm explaining about the question paper that you are going to get in mid examination of the next 2 days, next 3 days, whatever question paper. It's not like that. Okay, but thing is, maybe the numeric values may vary, but similar to these questions only, as under the problems you can expect problem questions. Maybe instead of giving 0.2, maybe 0.3 angstrom units, then find out the uncertainty of the momentum of an electron, like that may be asked. Okay, so unit 1 you got as one theory, one this problem. Internal choice is there. If you have attempted unit under unit 1, second question if you have attempted A and B, then need not to write the answer for 3AB, which is also from unit 1 only, which these two are also from unit 1 only. Either this or this you have to write as under the answer. Okay, now what are matter waves? Deduce the expression for de Broglie. So de Broglie equation and matter waves, regarding that here question was framed and a problem is given from again unit 1 only. R is there, internal choice, it is nothing but Schrodinger time independent wave equation is given, and calculate the stopping potential, that will also comes under the unit 1 only. Okay, so which are carrying equal marks here, equal marks here. If you attempt this, you are going to get 6 marks. If you are attempting this, you are going to get either here or here. You are going to get equal marks as 6 marks. Okay, so that is about the first unit. That is about the first unit, as like this we can say. Okay, so set 1 first unit, this is the situation. Now let us move to the set 2. Set to 2. Set to 2. And what are all the questions were given under the unit 1 itself? Unit 1 is second set, second question paper. If you take, see here, what is black body radiator? Draw the, there actually the first question is Compton effect, Compton shift, but it was not repeated here. It was not repeated here, you see. But this question is from the unit 1 only. Unit 1 only, but other question was given. What is black body radiator? Which already I have given as it is an important question. Compton effect, black body radiator, both are important, like that only I give. Okay, like this we can expect. And Heisenberg uncertainty principle is the next question, which cannot be seen. This question cannot be seen in the unit that is set 1. Set 1 questions are different. Set 2 questions are different. So under unit 1 you are going to get two questions as like this. Okay, now 1C 1D are from unit 2. 1C 1D are from unit 2 in second set. In second set I am explaining about in second set. Okay, like this. And this question as usual, that is from third unit. Only one question. Why? Because half of the unit only was completed. Na? So only one question we are going to give from the third unit as like this. You see, what is define the Hall effect like that? What is Hall effect? Define Hall effect. List the applications of Hall effect. Since it is short answer question, we are framing the question accordingly. Short answer means it should be of short only. Definitions, what is that, how, like that questions will be there. List, like that will be there. Okay. So this is about part A in set 2. These two questions from unit 1. Now part B, if you take, this is short answer question. Part B, if you take in this, they were from long answer questions. Long answer question means part B. As I told to you, second question and third question are from unit 1 only. One theory, one problem. One theory, one problem. But both are from unit 1 only. Here you can see that. You can see that. Okay. Carrying equal marks. Carrying equal marks. Now you say there some other question. De Broglie equations there they have asked actually. But here second question, if you take, describe about the Divergent-Germers experiment for the study of electron diffraction. See how the question was giving here. They are twisting the question, but thing is answer for Divergent-Germers is always will be the same only. You have to write about Divergent-Germers experiment, which is explaining about the wave nature of a moving particle. Particle is nothing but an electron actually. Okay, that thing only you have to write. Analyze the observations and draw important conclusions that could be drawn from it. Overall, you are going to write about the Divergent-Germers experiment by using a diagram, that is Divergent-Germers experiment diagram, and that results also you are going to interpret as under the long answer question. And here you see, as many times I told you that equal importance is given to the problems also, given to problems also. This and this, if you have attempted, then second question is over. Now here Compton effect is taken as the concept to frame the problem. Okay, like this can be instead of 6 maybe the 5, like that can be expected as the problems. All problems already have been solved in tutorial. If you once you go through that tutorial problems, everything you can see there itself. Every problem solution we have discussed in physical classes and even in the virtual lab also. Okay, have you solved this problem or not? Anyone can be checked by seeing your tutorial problem, that notes, tutorial notes. Have you ever solved this problem? Is it there in your tutorial notes? Please speak out. This problem have you ever seen to be this problem? మాట్లాడండి అమ్మా. Speak out.
Yes,
Total
sir, we did, sir.
55 students are there. No one is speaking. We have solved this problem, na?
Yes, sir.
Yeah. Okay. Now you see the third question is also from unit 1 only. That how you came to know, sir? Blindly I want to know that thing means here COs you check. If here it is 1, it is nothing but from unit 1. Here it is 1 means it is unit 1. If at all this number was changed, then we can expect that is from that particular unit. Okay, so 2 and 3 are from unit 1, and this is the problem. This problem have you ever solved or not? Can you check? An electron is confined in an infinite square well of width 10 angstrom unit. 10 into 10 to the power minus 10 means that only. Okay. Calculate the energy and wavelength of the electron emitted when the proton undergoes a transition from the. You have to. You can solve. Overall, it is nothing but a particle in a potential box. Whatever the problem is there, that problem only have been given here. Okay. So n equal to 1 is nothing but the ground state. N equal to 2 is the first excited energy level. That values you need to calculate here by taking a particle here. Okay, so you can calculate. So overall second question and third question are from unit 1 only. Is it clear? Set 1 and set 2, if you take overall what you have observed, two things you have to observe. First thing is what? By seeing the set 1 and set 2 question papers, what you have observed? Your observations I want. Tell me.
Questions aim is same గా లేవు different గా.
Yes, good. No question was repeated. But thing is, the second thing is, whatever the format that to be followed, it's nothing but first two questions from unit one means we are following that. Definitely, you will get the first two questions from unit one only. That is there. Second thing is no question is repeating here. No question was repeated here. Okay, so that is the second thing. Okay, now set one and set two like this. Okay, now as I told to you today, in today's session we are going to discuss about unit 2. What are all the important questions in unit 2 that we will see. Now I'm taking the set one question paper. As I told to you, which questions will come can be expected as under the unit 2? Tell me the question numbers here. Unit 2 questions. Unit 2 questions
CD.
are
C,
yes,
D.
yes,
CD.
yes. C and D. C and D. C. Define, here you see, infinite negative effective mass. Definitions. Which is called infinite effective mass, which is called negative effective mass. Like that. Okay. Next, mention the expression for effective mass of electron. Whatever the effective mass of electron expression only you have to write. Need not to derive here. Need not to derive. Okay. M star is equal to h cut square by dou square e by dou k square is the final expression. If you have written that expression, you are going to get 1 mark. For definitions, 1 mark. Total 2 marks. That's all. Is it clear? So that is from the unit 2. Now you see here what was asked. How do you classify the materials based on energy band structures? Explain with need diagrams. It is nothing but about what you have to write. Any idea?
Conductors, insulators, and semiconductors.
Semiconductors, their energy band gaps are there na. Conductors, if you take energy band structure, if you take conduction band is overlapped and valency band, the diagram and its properties, 3 or 4 properties. Again, insulators diagram and its properties, and the semiconductors diagram, energy band structure diagram and its properties. Overall it may be completed within one page itself. That is nothing but it carries 2 marks. For all diagrams, 1 mark, and for all properties, one more mark. So overall 2 marks. If at all it was given for 5 marks also, they will distribute into half like that. For diagrams, 2.5. For properties, 2.5 like that. 2 marks, 1. 5 marks, 2.5 like that. Okay. So here set one, if you take 1C, 1D are from unit 2. Okay. Now in this set one only, now we will move to the part B. Part B is long answer questions. Part B is long answer questions. Okay. So long answer questions, from where it will start, from what question to what? What is that question number?
Fourth.
2 and
Fourth one,
yeah,
sir.
yeah, 2 and 3 are from unit 1. Since here COs are given as 1, 1, 1, 1. That itself indicates, indirect indication, that is from unit 1. Now fourth question and the fifth question, any one have to be attempted by you. Completely have to attempt. It is nothing but if you are writing answer for fourth question, for A and B are mandatory for you. They are from unit 2. They are from unit 2. Okay. So here you see 4A, as I told you, a theory question. Analyze the chronic penny model using energy spectrum of an electron which is moving in a one dimensional periodic potential. Whatever the thing was given, stuff whatever was given here, overall you need to write about chronic penny model. Complete chronic penny model, that diagram, how the potential variation of potential energy with respect to the position of that particular electron, the diagram you have to draw. Square wells are there. They are nothing but potential well, potential barriers are there, that you need to draw. Next, the explanation and formula is there. One equation is there. What is that equation? Anybody knows that equation? P sin alpha A by alpha A plus cos alpha A equal to cos Ka. That expression you have to write. Then there is one sinusoidal form of graph is there, which is telling us that formation of energy bands in between the allowed and the forbidden energy gaps are there. Till that cos n pi is equal to minus 1 to the power n, it's expansion. So right side, left side, whatever properties of the right side are there applicable to the left side. That's why we are getting a sinusoidal with some dashed lines. Cutting points, intercepts are nothing but representing the allowed energy bands. The remaining between gaps are there, whatever between the allowed energy bands, they are called as the forbidden energy gaps. That thing you need to write here up to that one graph is there, one diagram is there. That by covering this you need to write. Okay, so chronic penny model, about chronic penny model, this may ask even in final exam for 10 or 12 marks also. Thing is, he don't consider here how many marks that it is carrying. Thing is, you have to write complete answer for given question, okay, within given time. 2 hours time was given, but thing is overall how many questions you are attempting? One here, any one you are attempting, it is nothing but one here. Here one more question and half, it is nothing but only 6a or b is there, half there, two and a half, and first short answer questions, that's all. Overall you are going to write around 4 or 5 questions, long answer questions. If you take 4 questions, if you take each one, you can write by taking half an hour time. Long answer questions as under, if you take all together as 4 long answer questions, half an hour time is there. It is not like that just writing definition and thinking that you are going to get the full marks. It's not like that. You have to elaborate whatever you have studied, whatever you have prepared, all thing you need to write on, you have to put on the paper, you have to present on the paper. Okay, so here you see internal choice, as I told to you, for AB if you have attempted, you have to write completely about this. Theory part, theory question is this one. And what is this B part? As I told to you, see, always a problem is there. Estimate the lowest two eigen energies in units of electron volt. I want final answer in electron volt for an electron in an infinite one dimensional potential well of width 1 nanometer. Have you solved this problem? Similar problems, at least similar problems have you solved? Finding the lowest energy level, first excited energy level, second excited energy levels in terms of electron volt, the final value, how to be convert from joule to electron volt. Have you solved these problems? Similar problems in class? Yes, yes. Okay. So what is that expression to be used here? What is that formula to be used here? What is that formula to be used to solve this problem? En is equal to, it is
En is
nothing but
equal to
all
n
part
square
together.
into E1.
Yeah, n square into h, n square into h square or h.
E1, sir. N square into E1.
Yeah, n square into e1, where e1 equal to, e1 value you must know now. First you have to find out the lowest energy level, ground level value. N equal to 1, e1, that is n square h square by 8 ml square overall. Okay, so by using that formula you have to calculate all possible energy levels. Okay, so this is 4a and b theory and one problem. Okay, now 5ab, if you comes to 5ab, 5a and b, these two questions are also from unit 3 only. How you came to know means, here you see course outcome of unit 2, course outcome of unit 2, it is nothing but it indicates indirectly from unit 2 only. Okay, so what is that question was given in this model question paper? Fifth question. This is from unit 2 or not? Is this from unit 2 or not? Or from out? It's nothing but out of syllabus. What is that question? Read out.
Unit 2.
Unit 2 only. Second part. Second part. Yes or no? Fermi Dirac distribution law. Okay. Overall is plotting a graph, everything was given here, but overall what you need to do is you need to write about Fermi Dirac distribution law and case 1, case 2, case 3, whatever are there, that you have to write. And at last there is one diagram is there, one figure is there. which is explaining about the probability function values with respect to the temperature versus the given energy level. Three parameters are there. Okay, that figure also you need to draw. Curves will come actually. Okay, I think all you know that graph. Okay. Now this is the problem which was given in unit 2. Fermi-Dirac distribution law is there na on that only second unit. If you take Fermi-Dirac distribution law problems only can be expected. None other concepts are there to solve the problems. Only Fermi-Dirac distribution law. Some percentage will be given probability values to be find out now. Okay. Find out the energy levels as like this. Okay, like the 3% of probability is given, and some e and e in ef difference is there. Find out what is the difference between them, like that. All these problems already we have solved actually. Find out the temperature value, find out the e minus ef value difference between the given energy level to the Fermi energy level, or find out the probability value. Three things only can be expected: find out the temperature, or find out the e minus ef value difference between the given energy level to the Fermi energy level, or find out the Fermi probability value, like that. Okay. Okay, so this problem also we have already solved, but whenever you are solving this problem, be careful about the units here. 8.5 electron volt is given. So what to do? You need to convert into that joules. Otherwise, the answer whatever you are going to get may vary. Why? Because that values to be taken here, values to be considered here, units to be considered here. Okay. Now 5a and b, if you take, these are all these two questions will comes under unit 2 only. Okay, in next class tomorrow we are going to discuss about unit 3a, first half of the unit 3a. That only one question, theory and or this one problem, theory or problem, theory or problem, 6a b, like this. This is about set 1. This is about set 1. Okay, if you come to set 2, if you come to set 2, similar to this only will be there, but questions may not be same. Now you see set 2, set 2. Now, what questions were asked under part A? You see 1C, 1D. What is that question was asked? Illustrate. Illustrate is nothing but neatly draw a diagram or graph or the figure you need to draw. Illustrate. Explaining with a diagram or a figure is called as illustrate actually. Okay. Illustrate ek relation of a moving particle in a periodic field. What answer to be written to this question? Relevant concept is what? Illustrate ek relation of a moving particle in a periodic field. What is that concept I am asking you to write here? Indirectly question was framed instead of asking about that particular thing. Illustrate ek relation. Ek relation is there in unit 2 or not? Ek relation
Yes,
is
sir.
there?
Yes, sir,
Okay.
in chronic penny model.
Yeah, in chronic penny model, after chronic penny model, Briglioni Jones ek relation is there. It is nothing but E versus K. K values are plus or minus n pi by A values we have taken. N pi by L or n pi by A we can take. Where L or A is the width of the potential, width of that potential well. So E on y axis and K values on x axis by taking like that. Don't get confused. Two EK graphs are there. One relevant to the unit 2, another is relevant to the unit 3. Unit 3 or 2, how you came to know means here itself given here. You see. In unit 3, whatever the EK graph is there, that is about to explain about the properties of direct and indirect band gap semiconductors. There is one diagram is there: conduction band, valency band. Directly electron is falling down and occupying the whole position. That is also EK graph. It is EK graph. EK relation is different with EK graph. Don't get confused. Check which to be written as the answer, which it is belongs to unit 2 or unit 3. You see, if at all it is given under the unit 2, you have to write about the Briglioni Jones. If at all it is given under the, so that confusion won't be there. Okay, if at all ek graph like that was given and unit 3 is there, it's but co3 is there, then it is related to unit 3. Okay, like that. Okay. Now you see fourth question. You see C D D. You see what is Fermi Dirac distribution law? Statement only he is asking. Statement only. What is that statement? What is Fermi Dirac distribution law? Fermi Dirac distribution law explains about the probability of occupying electrons from lower energy level to higher energy level. It obeys all these particles or electrons will obey a statistical distribution law. That statistical distribution law is called Fermi Dirac distribution law. At a given energy level, what is the probability of occupying electron? If at all it absorbs some energy related probability value is Fermi Dirac distribution law. That's all. Now direct you can draw a graph between energies of a particle. It is nothing but E on y-axis, the probability function values on one axis with respect to temperature. Only you need to draw that graph. Need not to write about the cases. Thing is statement you write, that Fermi-Dirac law f of E equal to 1 by e to the power e minus ef by kbt plus 1. Formula you write, direct you plot that graph. That's all. Since it has been given under the short answer question, whatever was asked that you write. Need not elaborate. Case 1, case 2, case 3 are need not to derive there. But here is it. Try to understand. In set 1, this question was asked under the long answer question. Whereas that question now here was asked under the short answer question with specified things only. Draw, that's all. State and draw. Accordingly, you need to write the answer. That is time management, we are calling it as. Okay. So C and D will comes under the unit 2 only as like this. So part A will covers the short answer questions and that can be expected as like this. Okay. Now, in set 2, now we are in set 2 now. Which questions can be expected from the unit 2 now means here itself you see. Fourth question CO2 CO2. Course outcome of second unit. Course outcome of second unit. Here itself it is indicating that this is from second unit. What question was asked in second unit? Two chapters are there na. This is from first chapter. If at all any unit has two chapters, one question can be expected from first chapter as under the theory, and one question can be expected from the second chapter. Try to understand. There is a very what we call a tricky thing is there. If you follow that, you can answer any question or any set that you have got actually. One question we are giving from one chapter in the same unit. One question we are framing from the second leftover chapter in that same unit. Effective mass of electron, you see, this is from first chapter in unit 2 only, first part. Okay. What was asked to define effective mass of electron, derive an expression for effective mass of an electron. It is nothing but derivation. M star derivation you have to write here. Okay. Overall this thing, that thing was given just to confuse you, but thing is by seeing this effective mass of electron you have to derive that expression. That's all. Okay. Next, here in unit 2, as I told to you, there is only one topic from which we can expect the problems, that is Fermi Dirac distribution law only. None other top concept is there to give the to frame the questions. So if the probability, sometimes as I told to you, sometimes they may ask to find out the temperature value, sometimes they may ask you to find out the e minus ef value, sometimes they may ask you to find out the probability function, how much value of probability is there, like that. Okay. So t or e minus ef or f of e values in general you have to find out. Okay. But specifically if they asked you to find out the E minus EF value in electron volt, means first you find out the value E minus EF in joule, then you convert into electron volt. At last also you can convert, no problem. Okay. uh, okay. And one more important thing is, when you are solving such type of problems, units conversions have to be done compulsory. It is why, because E minus EF by kb is there. Kb is Boltzmann constant. That value always we are writing in terms of joules only. Units are joule only. Okay, that's why E and EF values also you have to convert into joule and you have to write. All together you have to convert into electron volt at last. That is, if at all was asked to find out the E minus EF in electron volt means. Temperature always in Kelvin only. If at all given in degree centigrade also you have to convert into Kelvin. Okay, how to convert degree centigrade into Kelvin? For example, 20 degree centigrade is given. P value,
273 shipping.
yeah, 273 plus that is 20 degrees. It's at 293 like that. Okay, so one theory, one problem. Okay, this question R, as I told you, see, R is there. R is there. Don't think that here, if you have attempted for A here and 5B, if you attempt, you won't get marks for either 4A or 5B. Any one you will get. Why? Because completely you have to answer either 4 or 5 completely. There you have written answer for theory 4A. Here 5B is the problem. Na? I will solve this problem. Then you can solve. But thing is, which question have got the maximum marks? That only will be considered. Anyone will be considered. For example, 4A, while posting the mark, I will post it as a 2.5 marks. 5B you have attempted. It won't be counted, but you have attempted. Then 5B, for example, if you got 3 marks, then 5B will be considered. 4A will not be considered. If you are expecting full marks means full answer you have to write either 4AB or 5AB. Is it clear, students?
Yes, sir.
Okay, so that is
Yes,
very
sir.
important. Okay, so this is under the unit 2 and these two are here. What question was given as under the short and that long answer question under the theory? You see, what are energy bands? Discuss about origin of energy bands formation in solid. So this is nothing but the another question. Okay, so unit 2, if you take, these are all the questions that can be expected in a mid-exam question paper as under the model question paper as like this. Okay, so in today's class we are going to see glance only, need not to if I want to, if I start to explain about each and every topic in depth means it won't be over in a 1 hour actually. Okay, so unit 2 band theory and energy bands in solids are there na? Now if you take this second unit, these are all the topics as I told to you. Bloch theorem is there as the first topic, and free electron gas model is actually the first topic. Free electron gas model, it is nothing but classical free electron theory, quantum free electron theory, how they have explained about the electrical conductivity of metals, and the successes and failures of that are there in the first in the second unit as under the first topic. Next, Bloch theorem we have seen. Next, chronic penny model. Okay, next ek diagram in sequence if you take, they can be taken as like this. Next, classification of materials as conductors, insulators and semiconductors. Okay, and the second part, if you come, origin of energy band formations in solids, Fermi energy level, Fermi Dirac distribution law, and effective mass of electron as we discussed as like this. Okay, now which questions can be expected for final examination point of view or any examination point of view? As I told to you, these questions can be expected as important. ek diagram, as I told to you, and classification of materials as conductors, insulators and semiconductors. And this have been not yet asked, but you have to prepare and be ready if at all this question comes also. Okay, Bloch theorem also never asked actually, and Fermi energy level simple definition only, that's why cannot be expected. But these are under the long answer question. Chronic penny model, origin of energy band formations in solids, and Fermi Dirac distribution law as under the long answer questions, and the effective mass of electron. Now you see, you have seen the set 1 and set 2 question paper. Now you see, as under the long answer question, chronic penny model question was given or not? You have seen set 1 and set 2 na? Chronic penny model question was given or not?
Yes, sir.
Given. Okay. Now origin of energy band formation in solids. This question was asked or not? Have you seen this in both the question papers? Any one question paper have you seen or not? This also there. This also there. Fermi Dirac distribution law with cases explained like that is there. It is nothing but this also is there. And effective mass of electron, derive effective mass of electron is also there. Two questions, two sets of question papers we are preparing means in one set with internal choice, two questions can be expected, and another set with internal choice, two more questions can be expected. Why? Because there won't be any repetition of these questions. That's why four long answer questions. Anyone can be expected in any question paper. Like that here also. EK diagram, classification
Sir,
of
can we
electron.
expect other than these long answer questions from this chapter?
No, these are all the long answer questions. These are all the long answer questions. 99% these only will be given as under the long answer questions. They were represented with a red color mark. It depends on the concept and the content. Fermi energy level, for example, you take cannot be given as under the long answer question. Why? Because it's a definition and a small diagram. That's all. EF, about EF cannot be expected as under the long answer question. Content and the concept both are important. Is it very important concept or not? Like that. Okay, now you see Bloch theorem is there, which is important concept only, but the revision of this concept is the chronic penny model. So they always ask the latest model only, rather asking the old model. Actually, Bloch theorem is also explaining about the same thing whatever the chronic penny model is explaining, variation of potential energy when an electron is moving in a periodic field. Both were explaining about the same concept, but chronic penny model is the successful model. That's why successful model only can be expected as under the important question. Okay, so like this we can expect the questions in unit 2. Okay, and as I told to you here, there are some important topics are there. That is nothing but what is a free electron theory, classical free electron theory means what, and quantum free electron theory means what, and their successes and failures already you know. Okay, how it was explained also you know. A metal contains a large number of free electrons, and always they are responsible for electrical conductivity. Okay, so that is the main thing. Like this he was assumed actually. Okay, and these electrons are moving within the metal very freely, like how in a gas molecules will move. It's nothing but free electron gas model we are calling as like this. These are responsible for electrical conductivity as like that. That is Drude and Lorentz have been modeled as like this. Okay, so this thing, just once you go through all these properties you came to know. When you don't apply an external electric field, then all these charged particles electrons are moving randomly. So the the net velocity vector of all these moving charge carriers will become zero. When you apply electric field, then all these electrons which are called as free electrons are moving in a unidirection. That results in conductivity. Like that, these two scientists were explain about the electrical conductivity in metals. Okay, so according to these scientists, resistivity is directly proportional to temperature in metals especially, and that relation also they calculated as a rho is directly proportional to t to the power 5. And the thermal conductivity and the electrical conductivity also explained by this theory. And with respect to temperature, how it varies means it is varying as like this. That is the relation we are calling. Okay, and overall the RMS velocity vector can be written as like this. Electron is moving, na? So that RMS velocity of that moving electron according to the free electron gas model we can write as like this. Sigma is conductivity, can be written as like this. Sigma again conductivity in terms of mu mobility. Sigma finally can be written as like this. Okay, so that is about that free electron theory, classical free electron theory. Okay, and quantum free electron theory if you comes, then some modifications were done. Not all the charge carriers electrons are responsible, but only the electrons which are at a Fermi level, they are responsible for electrical conductivity. Like that, made a small suggestion in the classical free electron theory. Okay, Next, Bloch theorem we have seen. Bloch theorem, though important or not important, that I'm keeping aside. Thing is, what all the contents are there, and just a glance. Oh yes, we have seen this diagram like that. It is explaining about how the variation of potential energy of a moving electron in a periodic field. Then the potential energy is varying according to this Bloch theorem as like this. Okay, when electron is at positive ion side, positive negative, so zero, potential energy is zero. When electron is moving towards another positive ion side, slowly increasing, attaining maximum value, and in the middle maximum value between the two positive ions, and slowly it is decreasing as electron is moving towards another positive ion site. This is the model that Bloch was explained. Okay, but thing is it is successful up to some extent only. That's why another model was proposed by a scientist, Chronic and Penny model, that we are calling it as that model is very very important. Okay, so that Chronic Penny model also we have discussed in our theory class. Bloch theorem is the basic thing for this, but Bloch theorem is explaining the potential energy as like this. But if you take the Chronic Penny model, then the potential energy of that moving electron in a periodic field is moving in terms of as here like this: square well and barrier, well barrier. It is nothing but in a rectangular or square well, rectangular or that square form, rectangular or square form, they are moving. That potential energy is varying as like this. Okay, so if you take this point as 0, the width of this potential barrier is minus b, is nothing but b, and this is nothing but potential well, its width is a, as like this. By taking like this, these two scientists, by making so many assumptions, finally they derived one expression. Okay, what is that expression that they have derived? Just now I told, KPM, Chronic Penny model. This is the final expression they have derived by taking Schrodinger time independent equation and applying that to a moving particle which is moving in a periodic field. So final expression you need to write. This is very very important. If you don't write this, you won't get marks. P sin alpha a by alpha a plus cos alpha equal to cos ka. So by using this, by analyzing that equation, overall we have explained about the formation of forbidden energy gaps and the allowed energy bands. Okay, that are the observations you need to write accordingly. Now this diagram is very very important. You have to draw this diagram. Okay, don't leave this diagram, compulsory you have to draw. Where is that allowed energy band? Means this thick horizontal line is there na? This is allowed energy band, allowed energy band. And here also, wherever the thick horizontal lines are there, allowed energy bands, already it was mentioned as here. And this is another allowed energy band, thick horizontal line, thick horizontal, in between gap is there. That gap is forbidden energy gap. How you got this? Means by using this expression, cos ka is there, which is equivalent to LHS term, RHS, LHS. RHS term, if you take, it has some limits. That limits are applicable to this LHS term also. So accordingly, finally, we have drawn as like this. Okay, so that is about the formation of energy bands and allowed energy bands, formation of energy allowed energy bands and that forbidden energy gaps. Okay, ek relation, as you told, you ek relation is there, e versus k. Okay, that diagram how can be expected? Means e is the energy, k is nothing but on x-axis we have taken, and k equal to plus or minus n pi by a, plus or minus n equal to 1 pi by a, plus or minus n equal to 2 pi by a. So plus pi by a, 2 pi by a, 3 pi by a, I'm taking as the scale. Negative side plus pi by n, this side minus pi by n, like this. Okay, by taking as like this, and by writing n values here, n equal to 1, n equal to 2, n equal to 3, we are getting some regions. That region is nothing but the allowed energy band region, and whatever the discontinuities is there between one parabola shape to another parabola shape, discontinuity should be there. This is continuous curve. This is another continue curve. Between continue curve to continue curve, there is some gap. This gap is nothing but the forbidden energy gap. Okay, so like this, you need to draw this diagram instead of drawing continuously. I have seen in your assignment these things you have drawn continuously as a single parabola as like this. Don't draw like that. Am I clear, students? Here you see discontinuity should be there. There nothing should be there in between these two. Small gap should be there. Then only that is called as forbidden energy gap. Continuity wherever is there, that region is nothing but allowed energy band. Is it okay? Am I clear, students? Okay.
Yes,
So,
sir.
what I have observed in your assignment questions, answers, whatever you have submitted to me is continuously you're plotting a single parabolic shape of a curve as like this. Don't draw like this, and discontinuity should be there, and like this continuity and some discontinuity like this. From here you need to start continue up to this. Next give some gap as like this. How you are getting all these discontinuities? One question means here n equal to 1 plus or minus pi by a. N equal to 1 means plus or minus 1 pi by a. So plus pi by a to minus pi by a, you have joined that region as like this. N equal to 1 is this one, n equal to 1 is this one. N equal to 2, if you take that region is from here to here, from here to here, distinct region is there. It is nothing but the second region. First region, second region, in between some gap should be there. Why? Because you are saying that this is the first region and you are saying this is the second region. In between there should be some gap, then only they will be distinguished as a two different regions. That is nothing but here forbidden energy gap is there. Okay, like this. Ek relation, like this you need to draw. If all these questions in previous question papers, you can see all these. Okay, effective mass of electron. Okay, that is how to derive that expression, already you have seen. Okay, m star, two different types of effective masses are there. Their definitions you have seen, negative and infinite. And by taking this equation and by using this, by substituting that value in equal to h nu there, like this, equal to h nu, finally you got the final expression. As once you go through this topic you came to know what is that. Okay, now a value, first velocity we are finding, and acceleration again, next we are finding dv by dt. Okay, the rate of change of velocity is nothing but acceleration, that value you are finding. So f equal to ma, so in that you are substituting that value and finally you are getting the m or m star value. That is nothing but m or m star value. Finally you are writing it as like this, m star equal to this you are writing. Okay, so this is the final expression. Short answer means only you have to write the expression and the definitions of infinite and that negative effective masses. If it was asked under the long answer question means you have to completely derive this. H cut square by h cat or h cut h cap, both are same. Okay, square by d square e by dk square as the final expression. Once you go through, very easy these things actually. Okay, so like this is nothing but e versus k, and here de versus k and m star versus k. These diagrams once again you cross check with your classwork notes. If at all any mistakes you did in classwork, you correct them by seeing these diagrams. Okay, next, origin of formation of energy bands. Very closely if atoms are arranged, then what is happening? Overlapping of that orbits can be seen. It is nothing but overlapping of the wave functions of the electrons can be seen. Distinct, a single isolated atom, if you take single energy of that electron which is moving around the nuclei can be expected. If two atoms are brought together, then they are overlapping. Their orbits are overlapping, wave functions are overlapping, and two closest energy levels can be seen. E1 and E2 are closest energy levels. One related to this electron in this atom, another is related to this electron in this atom. Two atoms we have taken, and assuming that two overlapping of orbits are there like this. If three are taken, then three closest energy levels can be seen. If n number of atoms if you take, then n number of energy levels can be expected as very closely arranged. This looks, it looks like a single band. That is this, it looks like a single energy level, hence it is called as a band. very closely packed energy bands, energy levels. Okay, so this is also important thing. Yeah, this is important. Okay, next, classification of materials: conductors, insulators, and semiconductors. As three different types are there. Okay, what are conductors and their properties based on the energy band structure? Okay, these are all the properties. And the insulators, what are all the properties of insulators and the energy band structure? Gap is very high, you see. And if you take the conductors, if you take conductors, no gap is there, you see, is equal to 0. These diagrams are important, and three or four properties whatever are there that you need to write. Okay, next, semiconductors. What are semiconductors and their energy band structure and important properties about the semiconductors? Classification of materials and some examples also we are given. Comparison means like this we can compare them all together: insulators, semiconductors, conductors. Diagrams are important there. Okay, Fermi energy level, already you know what is that definition. At 0 degree Kelvin, the highest energy level that an electron can occupy is called the Fermi energy level. Okay, above Fermi energy level at 0 degree Kelvin, no electrons. Below, completely filled. Okay, and Fermi Dirac distribution law, which is explaining about the probability of occupying electrons at a higher energy level when the system or material absorbs the external energy. When system or material absorbs the external energy, electrons are absorbing that energy. Actually, atom is absorbing means electrons are absorbing. When electrons get excited by absorbing the energy, they will jump from lower energy level to higher energy level. At a particular given energy level, what is that probability? 100% or 50% or 70%? If you want to know, then you need to use this formula or the law, Fermi Dirac distribution law. This is nothing but that one. Okay, probability value here 0 to 1 we can expect. 0 means 0%, means never been occupied. 1 is nothing but 100%. In between any value can be expected. If at all zero point 0.6 you got here, it's nothing but 60%. E is the given energy level where you want to know the Fermi Dirac distribution law. This function. Okay, probability function value. If you want to know at given energy level, mean this is the given energy level. EF is nothing but the Fermi energy value. Okay, Kb is Boltzmann constant, and T is absolute temperature plus 1. This equation is very important. As under the long answer question, as I told to you, that question number of times it was repeated. Case 1, case 2. At 0 degree Kelvin, at 0 degree Kelvin, if the given energy level is greater than Fermi level, what is the probability value? When temperature is 0 only, but the given energy level is less than the Fermi energy level, then what about that probability value that we have seen? Fermi energy level is this one. Above Fermi energy level at 0 degree Kelvin, no electron is there, so 0. Below Fermi energy level, if energy level is given, then its probability value is 1. We're getting as like this. Okay, so the third case can also be expected. What is that? Other than temperature 0 degree Kelvin, but the given energy level is exactly the Fermi level. At Fermi energy level, what is the probability of occupying electrons if temperature is varied? Varying is nothing but above or below the 0 degree Kelvin. Then what will happen? Means 0.5%, 50% chances are there to occupy the electrons at Fermi energy level. As like that, we are saying case 1, case 2, case 3. EF above, EF below, and at EF, as like that. This is as I told to you. Fermi F of E versus energy levels, energy levels versus the temperature values. That is about the problems that important questions and the important topics. So in second unit, all problems that are related to Fermi Dirac distribution law only can be expected. Fermi Dirac distribution law. Percentage of the probability will be given, temperature is given, asking you to find out the difference between the energy values, as like that. In whatever the questions were framed, all they were belongs to the Fermi Dirac distribution law only. Like that. In a different manner, like this. 20% is given, 30% is given, 30% is given, temperature is varied, like that, values may vary. But overall concept is Fermi Dirac distribution law only. Is it okay, students? Okay, now I have posted a Google form to you, and today's dynamic code is 1234. Any doubts you can ask. Tomorrow, one more session is there. What I'm doing is third unit, half portion only. Na? So, first half an hour, I will complete this question paper and the important questions of the half unit of the unit 3. If at all time is there, then we will see the fourth unit. Otherwise, we will leave it here itself. Why? Because for mid examination, only 2.5 units are the syllabus. Na? So that you can write from Monday onwards. Is it okay? Please respond.
Sir, I submitted the correct code, sir, but due to network issues, sir, it have shown the wrong code.
So same with
Wrong,
me.
Sir,
wrong
everyone
code
is
like that.
showing same, sir.
Sir, it
Wrong
is
code like
showing
that
that
you
you have
got. Huh?
already responded, sir.
Wait a minute. Actually, the code which I have selected. 1 minute.
Sir, it is not showing to fill only, sir.
Wait.
Yes, sir.
What that problem you are getting? One, two,
It's
three,
Already,
not
four.
opening. It's
Not
showing
opening.
it's all. Uh,
already responded, sir.
Already responded like that. You are getting a message.
Yes, sir.
Wait. See, I'm sending one more this link to you. Use this link. 1234 is the code. Use this link and your attendance. 1234 is the dynamic code. One of you confirm. Is it okay now?
yes.
Yes, sir.
Okay.
Yes, sir.
See, all these PPTs, material, videos, everything was posted in our LMS. Once you go through that LMS, you came to know what was posted actually. Utilize that material.